Okay.
So exponential growth. I'm going to talk about bunnies here because we know that bunnies are known for reproducing like crazy. So let's say we have a bunny that we start off with, and that bunny has 2 baby bunnies. Now, if you know anything about bunnies, they're not just going to have 2 baby bunnies. They're going to have like 5 or more. And let's say each one of those has 2 bunnies. So Grandma Bunny up here already has 4 grandkids. Yeah? And say that one has 2, and that one has 2, and that one has 2, and that one has 2.
Oh my gosh.
We get to a lot of bunnies really quick, don't we?
Yes.
That's called exponential growth. That's not like humans where a person has 1 kid, and maybe they have 1 kid. Well, they might have 2 kids, but it takes a lot longer for that process to happen than for that process, right? So this is what we call exponential growth. It's not like, oh, the population of bunnies increases by 2 bunnies every year. So it's 4 bunnies this year, 6 bunnies next year, 8 bunnies. No. It's 1, 2, 4, 8, 16 would be the next one, 32. It gets really big really fast. Okay? That's an example of exponential growth. Exponential decay would be the opposite. You start off and you get small really, really fast. Okay? So, exponential growth. We are going to start off with a mother function.
Yeah.
That's what I like to hear. All right, so here is a mother function. And the reason why this is a mother function is because we have a base, which would be 2, and we have an exponent. There's absolutely nothing that I could interpret as an H or a K. Do you see that? There's no H or K anywhere on there. Now, the general form, I don't see it on here. The general form of an exponential function is y equals ab to the x. And we'll throw in h and k in there in just a minute, but starting off with just ab to the x. The 2 in this equation right here, do you think that is the a or the b?
B.
The b. What makes you say that? Because it's got the exponent, right? So I have a b value of 2. Okay? The b value is also known as the multiplier. And when we're talking about exponential growth, we're talking about any exponential function, so in the form y equals ab to the x, that has a b value that is greater than 1. You with me? When we get to decay tomorrow, the only difference in the equation is that decay has a multiplier or a b value of what? Between 0 and 1.
So fractions.
So what about less than? That's not covered, isn't it? I have 0 to 1, and I have greater than 1.
Fractions.
Where's less than?
Pi.
Less than just flips it.
What do you mean?
Less than means you have a negative, and the negative sign would actually end up going on the a value, making it a vertical reflection. So it doesn't affect the growth or decay. It just makes it a reflection of growth or a reflection of decay. So yes, I did hear someone say fractions. Decay is fractions. However, it's not all fractions, because remember, there are fractions that are greater than 1. So if I had a multiplier or a b value of 3/2, that's still growth because it's 1.5. Okay? So, for this guy right here, I'm going to tell you right here that in the parent function, h equals 0 and k equals 0. You're going to want to know that. And you'll see why in a minute, because you'll see where h would go and where k would go. When we do this, our h value determines what goes in the middle of our XY chart. Do you follow? So far? Let's see, I need another color. Your K value, not that color, tells you about your, what's called asymptote. Okay? My asymptote is K equals 0. That is the same as the line Y equals 0, which means I have an asymptote right there. And you draw it in just like you would draw in like an axis of symmetry or something like that. Except your asymptote for all of these exponential functions is going to be horizontal. Now she says here, draw in a horizontal dotted line. Dotted line if you have the same color, or if you have a different color preferably, because that makes it easier for me to grade, you can just do it solid. Okay? And the equation of that line is y equals k. So for this example, it's the line y equals 0. So, what is an asymptote? Let's talk for a minute about an asymptote. You ready? All right. Okay, so you're going to go up and stand by the whiteboard. You don't need a pen or anything. But here's what I want you to do. You don't need that. Put it down. I want you to try and stand in the same place as the wall.
What?
Try and stand in the same place as the wall.
So you want me to run through the wall?
So what am I asking you to do?
It looks stupid. You want me to do it? I can do it. I'll try to do it.
So I was asking him to do something impossible, wasn't I?
Yes.
Not just to stand next to the wall, but to actually physically stand in the same place as the wall. You can't do that, can you? The wall is an asymptote. That acts like an asymptote. It's a border, okay? You can't actually be in the same place as it. You can get closer and closer and closer and closer, but you're never actually going to be in the exact same place. It's not possible, okay? So what this asymptote here is doing, it's giving us a boundary or a wall for our graph. Our graph cannot pass this asymptote. So if my graph is entirely above, there is no part of it that can go below the asymptote. Or if my graph is below, there is no part of it that can go above it.
Can a point be in the asymptote or no?
Can what?
Can like 1 point be in the asymptote or no?
1 point be in the asymptote? No. Nope. Unless you could make your finger go in the exact same place as the wall.
Okay.
Nothing can be in the exact same place. Okay? So, everyone okay with H and K? You'll see more clearly how to find that once we get to ones that actually have things that are H and K. But in this case, H is 0, K is 0. So H is what gives us our starting point for our XY chart. K is what gives us our asymptote. How do you think I fill in these values? I plug them into the equation. She has the work written there. I'm just going to go to my calculator. 2 to the negative second power is 0.25. Why is it 0.25? Because 2 to the negative second is 1 over 2 to the positive second, which is 1/4, right? Okay. What about 2 to the negative first? What's that going to be?
0.2?
No. 0.5, because it's 1 over 2, right? What about 2 to the 0? 1. 2 to the first?
2.
2 to the second?
4.
4. Now, when you're doing these, in general, from that H value, one direction is going to get you decimals, the other direction is going to get you nice numbers, usually. Okay? So just expect that. Let's look at this right here. Negative 2, comma 0.25. So it's just barely above that asymptote. Yes?
Yes.
Negative 1.5, a little bit further above that asymptote. 0, 1. 1, 2, and 2, 4. So, if you can kind of see, it's getting closer to the asymptote. It gets all the way down to 0.25. But guess what? Even if I plugged in negative 6, 2 to the negative 6th power, I still don't get 0. I get a number that's really small. Woo-hoo, you can't see it. I get a number that's really small, but I'm never actually going to get 0 because 0 is that wall. I can't actually get 0. So what does my graph look like? Well, when I connect my dots, it's going to get closer and closer, and it's just going to kind of ride along next to that asymptote. Make sense? Now, why is this exponential growth? Well, if I'm looking at my graph and I start from left to right, remember I kind of taught you how to read from left to right, how if you're a little person and you're walking on the graph. Do you see how you're starting on the asymptote and then you are getting further away from the asymptote? That makes it growth. Decay would be getting closer to the asymptote as you walk from left to right. We'll see that tomorrow. Let's talk domain and range. What can you tell me about my domain? All real numbers. Why do you say it's all real numbers? There's an arrow going this way forever. There's an arrow going this way, which means it's going up and out forever. So that's why my domain is all real numbers. What about my range?
Y is greater than 0.
Y is, obviously there's a line that Y can't cross. And that line is at 0. So what do I say about Y and 0? It's greater than 0. Could I say that it's greater than or equal to 0? No, because it can't be on 0. Right? So it can only be greater than 0. It might be only slightly greater than, but slightly greater than is still greater than. Okay? So?
Yeah.
All right. Let's look at this guy. How is this one different?
There's a negative.
There's a negative in front. That negative means I have an A value of -1. Our H value is still 0. Our K value is still 0. So, just like before, my H value tells me what goes in the middle of my XY chart. Yeah? And what does my K value tell me?
Your asymptote.
My asymptote. So there's my asymptote. And how am I going to fill out my XY chart? I have 0 in the middle. I'm going to fill in some values around. Now, if I plug in -2, I have 2 to the -2nd power, which I know is 0.25. Right? But what does that negative sign in front do?
1.
It makes it -0.25. If I plugged it into my calculator instead and I said -2 to the -2 power, there's my -0.25. Because that negative sign is not in parentheses, that changes things. What would -2 to the -1st be?
Negative 0.5.
-0.5. What's -2 to the 0? -1, right? Because this would be 1 times that negative. 2 to the 1st is 2. With that negative makes it -2. 2 to the 2nd is 4. With that negative makes it -4. How is that chart different than the one above it?
Let's go.
It's just all negative.
Yeah.
So let's see. -2, -0.25. -1, -0.5. 0, -1. 1, -2, and 2, -4. So again, I cannot cross that asymptote. Now, is this exponential growth?
Decay.
It's not decay, because as I'm walking from left to right, I'm still getting further away from the asymptote. So it is exponential growth. It's just reflected. Okay? It's just flipped upside down. Okay? It's exponential growth reflected. What's my domain? What's my range?
Y is less than 0.
Y is less than 0. Okay? What about this guy? Y equals 5 to the x. What's different about this one?
It's a 5.
It's a 5. So in other words, it's kind of like a different parent function. Yeah? My h value is still 0. My k value is still 0. So I start off with my h value. in the middle of my XY chart. And what does my K value tell me?
Asymptote.
My asymptote. All right, fill in some values around. And let's do this. 5 to the negative second power. That would be 1 over 5 squared, right? Or 1 over 25, which is 0.04. Change that negative 2 to a negative 1. 0.2. What's 5 to the 0? 1. 5 to the first. 5 to the second. 25. So do you see what I mean about exponential growth getting really big really fast? Okay. What do you notice is different about this XY chart than the one we did before? Or I should say than this one, because it was positive.
That's larger numbers.
It's getting bigger faster, isn't it?
Yes.
This one got only up to 4. This one gets to 25. Why do you think that is?
Because of a higher value.
Because powers of 5 get bigger faster than powers of 2.
Right.
Powers of 7 would get higher faster than powers of 5. So you're not going to see on a test y equals 7 to the x. Because the grid that we would have to provide for you to be able to actually graph all those numbers would be huge. Okay? That being said, don't freak out if you're getting large numbers, because the bigger your base, the bigger your numbers are going to get naturally. All right, so negative 2, 0.04, I can just do, it looks pretty much like 0.25, because by hand that's as accurate as I can get, right? Negative 1.2, pretty much in the same place, though it is slightly higher, right? Because 0.04 is smaller than 0.2. 0, 1, I do want to see that y-intercept is important. 1, 5. And 225 is off my graph, right? But I need to be aiming that direction as I graph it. So, I don't want to see your graph just cross do you see the line of 2 right there? I don't want your graph to just cross through that line, because it technically can't cross through this grid line until it's 25 high. So just aim towards 25 as your next one. Does that make sense what I'm saying? What's my domain? What's my range? Y is greater than 0. All right, going back to the base of 2 to more reasonable numbers. We've added a value. Is that value with the x?
No.
No. It's a k value. So in other words, if I took this equation right here, I'm going to add a little to it. H would be in the exponent with x, and k is at the end. Same order it's always been in, right? So here I have an h value of what? 0, because there's nothing in the exponent. I have a k value of 3. So my xy chart is still going to have an h value of 0 in the middle. I'm still going to do negative 1, negative 2, 1, and 2. But my asymptote is different now.
Yeah.
My asymptote is not at 0. Where is it?
3.
It's at 3. What is that going to change when I move my asymptote?
The graph's go
It's going to change my range.
Yeah, range.
My range is not going to be y is less than 0 or y is greater than 0. It's going to either be y is less than 3 or y is greater than 3. All right? So let's plug in our answers. Well, 2 to the negative second I know is 0.25. Plus 3 would be 3.25. And yes, you could do this on your calculator if you want. 2 to the negative first is 0.5. I know that from up here. Plus 3 is 3.5. 2 to the 0 is 1. Plus 3 is 4. 2 to the 1 is 2. Plus 3 is 5. And 2 to the second is 4. Plus 3 is 7. So if you look at it, all of these y values right here are the exact same as these guys, just increased by 3. Which means I have a shift Where?
Upward.
3 up,
Oh, up 3, yeah.
because that's what a k-value of 3 means. So let's plot these now. -2, 3.25. -1, 3.5. 0, 4, 1, 5. And 2, 7. And again, you cannot cross through that asymptote. What's my domain? What's my range?
Y is less than 3.
Y is greater than 3 because it's above that asymptote. Pretty easy, right?
Yeah.
What's different about this guy?
It has a H value.
It has an H value. Now, in the past, we have always had to change the sign of H. Do we still have to change the sign of H?
No. Yeah.
Yes. You always have, you always will. And it has to do with the fact that it's got that negative sign there in the formula. So you're always going to have to change it when it's got that negative sign. So my H value is -3. That means that -3 is what goes in the middle of my XY chart. So what are my values around there going to be? -4 and -5 on one side and -2 and -1 on the other? Yes?
Mm-hmm.
Okay. What's my K value?
0.
So where's my asymptote?
0.
0. Because K is always your asymptote. So now let's plug these in. This is going to be a little bit different. Watch as I plug this into my calculator, okay? -5 is my first X value. So I'm going to plug it in 2 to the, since you have an H value, you've got more than one thing going on in your exponent. Please open parentheses so that your calculator recognizes everything that you type in now as being part of your exponent. So I'm going to do -5 plus 3, close your parentheses. That tells my calculator that -5 plus 3 is all in the exponent. If I had a K value, I would plug it in after I close those parentheses. Okay? That gives me 0.25. Interesting. -5 plus 3 is -2, so that's really 2 to the -2nd power. All right, now go change the -5 to a what? -4, 0.5. Huh. Now go change it to a -3, 1, -2, 2, and -1.
4.
Because -1 plus 3 is actually 2, so you're really calculating 2 squared. Interesting. All right. -5.25, -4.5, -3.1, -2.2, and -1.4. What did that change from the parent function? It shifted it to the left how far? 3. Does an H value of -3 match up with the description of being shifted to the left 3? Yes. So all the descriptions you know still apply in the exact same way. What's my domain? And my range? Y is greater than 0. All right, one last example. Now, this is where she has typed out the full formal definition or the full formal equation. That's just what I wrote up here. Yeah? This one has both an H and a K. All right? So, let's fill in some information here. What is my B value or my multiplier? 3. So this actually is not a transformation of this parent function, right? Because this one, the multiplier was 2. What is my H value?
2.
Positive 2. That's going to tell me what?
You're just starting over your
My XY chart.
yeah.
Yeah? So I'm going to fill in 1, 0, and 3 and 4. What is my A value? 2. So is my graph going to be above my asymptote or below my asymptote?
Above.
Above. Whenever A is positive, your graph is above your asymptote. When A is negative, you still have growth. It's just growth reflected. And it's below your asymptote. What's my K value?
-1.
What does that change? What does that move?
It moves right to the left.
Your asymptote down 1. So my asymptote is the line what? Y equals -1. Yes, you must put the y equals because that's what makes it a line. What do you think my domain's going to be? Do you think my domain's ever going to change?
No.
Nope. Because my asymptote's always going to be horizontal. Next semester it'll change, but not now.
What do you put at centered at?
Don't worry about this centered at part. That's mainly just telling me what's this point. That's going to be like the center point of what we're graphing. Okay, so I'm going to start plugging in values. Now, be careful how you plug it into your calculator. You need to make sure that your calculator knows that the 2 is not a part of the base, right? I'm not doing 2 times 3 and calling this 6 with an exponent. It also needs to know that the -2 is part of the exponent and the -1 is not. So I'm going to do 2 times 3 to the open parentheses 0 minus 2, close your parentheses. Do you see what I've got here? 2 times 3 gets that exponent. Close your parentheses and then put your -1 in. -0.78. I'm going to call that -0.8. You okay with that?
Yeah.
How did I get a negative number?
Because the asymptote is down 1.
Because the asymptote is down to 1, I can get a negative number as long as it's still bigger than -1. And that is. So now I'm going to arrow back and I'm going to change that 0 to a 1. -0.3. Now I'm going to change that 1 to a 2. I got 1. Remember how I said 1/2 would give you ugly numbers? The other half gives you nice numbers. Usually. Now I'm going to put a 3 there. Gives me 5. And a 4 gives me 17. So there's my exponential growth. That last value, you're always going to get one that, I shouldn't say you're always, you're usually going to get a number that's pretty big that you're not going to be able to fit on your graph. All right? All right, 0, -0.8, 1, -0.3, 2, 1, 3, 5, and 4, excuse me, 417 is up there. And again, do not cross that asymptote. What's my range?
Y is greater than -1.
Yep. Now, transformation. If I asked you to describe this, what would you say? Since I have an A value of 2, I have a vertical stretch of 2. Right? Since my H value is 2, what else do I have?
Shift right. Horizontal, shift right.
Shift right, 2. You don't need to say horizontal if you include the word right or left.
Okay.
That's implied. Okay? If you just say shift 2,
Okay, yeah.
that's unclear. All right? And I have a K value of -1, so I also have a shift down 1. Okay? And this box pretty much summarizes everything that I've talked to you about there. B, really quickly, I don't think I addressed this. It has another name. It's called a growth factor, or it's called a multiplier. The book uses multiplier, I believe. Growth factor really only applies for growth. Multiplier applies for both growth and decay. Okay? Any questions? All right. Happy studying.